Hi, I'm Chris Erickson, and I'm the president of Datifex. We have a suite of interactive 3D web applications for digital twins, command control and intelligence, logistics, and LiDAR. These applications bring together many sources of data and subsystems controls, as well as user interaction into what we call a single pane of glass. They give context to tremendous amounts of information, which lets us make faster and better decisions. They're also natural and familiar. This means that you don't have to be a system specialist to understand what's going on. It also means it can be used for collaborating and for training purposes. The IntelliView engine is the core of these solutions. It's a set of high-performance game engine libraries that can manage hundreds of thousands of objects and how users interact with them. The web app solutions manage how the data and controls work together, which can include AI, optimization, physics, and other kinds of algorithms. Since our solutions are web apps, they run in any browser, on any operating system, and any device. That includes phones. There's no software to install either. We work with OEM clients, end users, and consulting firms. We license our IntelliView engine and the web app solutions, but because of our broad experience in building digital twins and command and control applications, you'd want us to engineer and develop the applications for you. We'd implement the system and then maintain and iterate through the various versions after that. And because the applications are written in common JavaScript, you can take over the solution anytime you want. Here's an example of a digital twin application. This is the HMCS Montreal. The goal here was to bring together all the various subsystems, including the weapons, the radar, countermeasures, propulsion systems, all into a single model. The idea is that you want to be able to click on each one of these subsystems and bring up its detail. You want to see maintenance records, you want to see statuses of sensors, you want to see the history of the sensors. You also want to be able to click on the videos to see what's going on in real time near those subsystems. One of the important functions was to be able to see the smart radar beam and to see how it intersects with other ships and with the helicopters as they fly by. This is called a RADHAZ hazard. Here's an example of a situational awareness application. In this case, what we're doing is showing the flight path of aerial vehicles over 3D terrain. And in this case, the applications could include, for example, missile defense, but also swarm drones, where you have 10, 20, 30 drones flying around in the air at the same time. And this situational awareness application will show you where they are and what they're all doing at the same time. Here's an example of our terminal view. This is the front end of GE Transportation's Smart Intermodal Management System. It combines a tremendous number of systems and complex databases together into a single visual that can be used by everyone from the person in the pickup truck in the yard all the way to central command within the United States at these various rail yards. Here is another example of a digital twin. NRC Aerospace built a flexible fuselage lab to research passenger experiences. The problem was that the researchers had no way of seeing the thousands of sensors in this new lab. So we built a digital twin of the fuselage lab so that we can see sensor data in real time. The results were used for research, but they were also used to communicate to their airline and aircraft manufacturer clients. That's it for now. I'm Chris Erickson. You have my email. Let's get together and talk more about digital twins and command and control applications.